Welcome to functional programming in Kotlin for AndroidDevs. So for those who don't know me, I'm Hari. I work for VTransfer. It's a creative product company. It's also in New York, but I'm based out of the Netherlands. But I was born and brought up in India. I moved to the Netherlands for work. And I'm also an Android developer by day. I also like design. I like product design, illustrations. So yeah, that's my free time thingy. And I occasionally blog. I was blogging continuously before pandemic, and after pandemic, a lot of things changed, priorities changed. So yeah, and I've been speaking in DroidCon since 2018. So let me summarize this for you, like why this talk exists, because you might be asking this question. Functional programming is not a new thing. It's been there ages since object-oriented programming exists. And we have been using Java from 2012, like since when I started my development. And 2018, I think, 2017, I/O and Google announced first-class citizenship for Kotlin in Android development world. So that was a little exciting. And Kotlin had, interestingly, given first-class citizenship to functions. And there were all of the pure functional-oriented programming languages. So I come from, I knew only Java. I started my career immediately after my university. And I wanted to learn functional programming, but it was really difficult to map my mental model from Java to another language. Then to understand a different concept, I have to speak a different language. It's like trying to understand a conversation that is in French, but I know only English, and how do I kind of figure out the functional programming as a paradigm? And also, I was also one of the developers who just used Arrow because it was cool in Android. And you had all the fancy types. But then that was my old, when I was beginning my career, that time I used Arrow, and then I'm not using it. But I really had a question, why? Why does it have to be different than object-oriented programming? Why? What problem does it solve from object-oriented programming? And why we are using certain types in Arrow? What does it solve? What does it give? So I had all these question marks floating around, and then I constantly kept tab on, like when my experience grew, I came to know a lot of things, speaking to different people. I kind of figured out all the missing pieces in the wall, and I had one eureka moment, and finally it was all about mathematics. So the term function itself, it means it's a mathematical function. So then this talk came in, like if someone wants to use Arrow, like you should actually understand why you're using it and what is the functionality of the API gives you and how you handle it. So all these topics will be covered in this talk. Having said that, let's set the expectations. So we are going to understand functional programming as a paradigm with respect to mathematics. Don't worry, it won't be a huge math. Even I don't like math. So it's going to be like very like 6th grade mathematics. And we're going to be talking about pure functions and pure effects. Pure effects will be touching a little bit because it is an ocean of things, how you handle effects of a program. And we'll be taking some default functions of Kotlin just to try to understand it mathematically first. Then you actually know what happens under the hood. And two important concepts, which is function composition and currying. They actually kind of lay the magic or the super nice API that a functional programming offers. And finally, a little bit, I'm going to touch Arrow so that it makes sense why Arrow exists and how you can use with that functional programming language knowledge. And my final thoughts, what you can take home, what you can apply in your projects, and how you can sell the idea if you really want to. A small disclaimer, like there will be some mathematical concept, but it's not that hard. But I also understand that some of us would be in the spectrum of not understanding mathematics properly. So I have toned down the functions that you see and the programs that you see to a very basic level. So for those who understand mathematics, you would feel like this is very simple. But for those who don't understand math like me, like numbers dancing, you would feel a bit comfortable, I hope. I've tried my best. So functional programming, what does it advocate? If I want to just put 2 words to it, it advocates safe programming. It says object-oriented programming, you have a lot of ways the error would be occurring, you wouldn't be handling it, and functional programming would make your program safe. That is the fundamental ideology in how that concepts move. And it does have a boundary for us, like when you're practicing or writing functional programming, you have a set of restriction that you cannot step out of it. And if you do, it just makes your programs unsafe. You will be having side effects in your programs. You'll be having unexpected errors, exceptions thrown, and everything. So some of these points are like avoiding sharing mutable state. Like you shouldn't be sharing mutable references. Like you would be doing this best practice in the view model where you wouldn't be sharing the mutable live data or flow. Rather, you would create something to share it to the view, which is immutable, where it just observes. That is a start, and it is a kind of a pivoting concept for functional programming. And avoiding complex structures, like if it's just one control structure, it's fine, but if you're nesting a lot of things inside, you would have side effects, meaning you may get some unexpected errors at some point. And controlling the external efforts. All the things in a function should be from the input, but it shouldn't be getting any instances that's from outside or any mutable instance that's from outside, which makes a lot of changes, and that brings in a different effect or a result of a program. And exception throwing. This is something very important. Like you should never throw an exception. And finally, making the programs as simple as possible and easily testable. Now, you might be wondering, this is a lot of boundary, right? Like, why would, we can take it easy, but why such restrictions? Because at the end of the day, that's how functional programming is, the paradigm is. For our apps, like using day-to-day apps, it's fine, but if you're meddling with the medical system where an error can cost life, or even you're launching a satellite, making programs needs to be safer and well testable. So that is a different crowd for which you need to follow super strict. But for us, we have these principles, and some of the libraries the Kotlin offers kind of makes it easiest for us. Another 2 words for us, referential transparency. The name sounds fancy. So it is a technique to write programs where the outcome of the program is always predicted by us, and we know it for sure that there won't be another imaginary outcome that can come at any cost. And you need not have the same result of the program, but you can have different variations, but that variation should be only based on the input. You supply one input, you get an output. You supply a different input, you get a different output, but it shouldn't be based on something that's inside the program. Rather, it should be based on the input that it comes from outside. So you can remember this term, referential transparency. We'll be seeing it at the last. Now the definition of the functional programming. Don't worry if you don't get this definition now. We'll be going through some of the concepts, and finally we'll be looking at the same definition. Let's see if you pick up a few of the statements there. So functional programming is about thinking a software in terms of writing pure functions. I have explicitly cut down a line, pure functions and handling pure effects, because we'll be covering effects less, so I'm just sticking it to pure functions. It avoids the concept of shared mutable state, like I mentioned. And finally, this line is very interesting. Functional programming emphasize on expressions and declarations rather than execution of statements. Now, in Java, if you remember, like what are functions, it also has, sorry. The functional programming, if you look at the object-oriented programming, when you talk about functions, it also has a name called methods and procedures. And if you look at the definition of them, it says a set of execution of statements sequentially or asynchronously, depending upon how we handle the stuff. But functional programming talks about functions as an expressions and declarations. We're going to see what this is. Now, for a moment, let's forget this methods, procedures, functions that you have been writing for a while, and go to the mathematical definition of a function. Now, you would have, please raise your hand if you have done this diagram in your school, where you map domain and codomain. Yes, I see many of hands. So this is what a function is in terms of programming, but let's stick to mathematical now. So function x plus 1 is an expression. It is not something that is writing to the database. It's not a use case. Let's avoid those type of thoughts for now. So it's just an expression, x plus 1, 2x plus y, an expression that gets substituted. Now, domain is a set of values, and each element would be applied to this expression, and you get the image in the codomain. Now, for the function to be pure and respect the domain and codomain relationship, it has some boundaries, like not to cheat or something like that. So there cannot be elements in the domain which, without any image on the codomain, like 2, 3, 4, 5, 7, 8, let's say if there is a 9, the 9 cannot be left out. If it is left out, there is another category called partial functions, which is another ocean, which we are not going to cover now. But for pure function, at least, the domain should always have an image in the codomain. And the value of the domain cannot have multiple images in the codomain. Like 2 cannot have 3 and as well as 4. If you imagine here, the input 2, 3, 4, 5, 7, 8 just has one result, one outcome. It can never have another outcome. There is no exception, if you can imagine programmatically a little bit, this mathematical concept. So you cannot never have an exception or another image. So for this input, this is the exact output. And you cannot have multiple outputs for the same input. And this is the mathematical notation of that function. Now, pure functions, what we saw example pictographically before, that is pure function. And these are some of the conditions. The function should always return a value, check. It must not throw exceptions or errors. It was just giving one direct image for the input. It must not mutate or change anything. For example, if we go back a little, so let's say there is a mutation, the 2 comes in, something adds the 2, changes the argument, and then so the image completely is different. So then you have the possibility of having the second point violates, like it cannot have multiple images. So that's what it speaks, and it shouldn't mutate or change its argument. And finally, for a given set of arguments, it should always return same value. Now, pure functions we usually write for computation purposes. And the computations can never go wrong if we follow this boundary. So pure function is mostly 100% for computations, and pure fx is for all other use cases that we handle the outcome of that function. The function gives a value, the function gives a state, the function gives any value, flow. How you handle that is pure fx. Now we are talking about pure functions for computation. So imagine numbers kind of right here. Cool, a pop quiz. Consider this function, ignore the negative values right now. Raise your hands if you think this is a pure function. Cool. Raise your hands if you think it's not a pure function. Sorry to disappoint you, it is pure because it returns, the infinity is kind of a instance of the double, so the state is handled and there is no mutation of the internal values, and it always returns the same value for x and y because double. Cool. Another one, like very dumb function. Nobody writes functions like this, but intentional. So it takes in a value and a list, and it adds the value and sends the list back. Raise your hands if you think it's not pure. Yes, pure. Very less. So majority of you are right. It is not pure because it clearly mutates the argument that is passed as the input. With that knowledge, let's take the functions that we offer in Kotlin and then try to understand it a little bit mathematically now. Map, I'm sure every one of us would have used this for sure, like using a mapping of lists, convert into all the backend that we get. Yeah, you know the story. So let's understand this mathematically first, like ignore the programmatically. So it's an expression, right? The map takes an expression, function f, which takes in a and sends b. So we have a set a, list 1, 2, 3, and you apply that x plus 1. So each element, this expression is applied and you get the result, which is the codomain relationship basically. And programmatically, you know how it's used. Same way reduce. Reduce basically reduces the list into a single value. So for that, if we understand programmatically, it takes in the first 2 elements, adds them, then for the x1, the result becomes the x1 for the next consecutive step. So that's why it performs the computation. And this is how the programmatic result comes in, and this is how we use it in, the mathematical result, and this is the programmatic result that we have. Now, coming to function composition. Please raise your hand if you already know this, or this is completely new. Cool. Okay, now majority of them don't know. You're in the perfect talk. So, function composition is a technique which will allow you to compose the bigger picture, like bigger function, using smaller functions. For example, the happy Lego is dancing. So every building blocks, if you imagine in Lego as a function, you can put together and build something wonderful that does an amazing job, like a car, or you can build anything using Lego. And if you're a musician, I can give you another example that you can relate with. Like every note, the musical note, is a function which does one thing, one sound. But you put together, you make an orchestra, you can make a symphony, you make a nice music, jazz, electric, everything. And coming back technically, it's an operation on function to produce new functions or results or effects. Imagine like binary function, like 1 + 1 is 2. That plus is a binary operation. Same way, we apply binary operation on functions to get new functions. Now, let's understand functional composition mathematically, quickly, and then let's go to the code. So for now, we have two functions, f and g, x + 1 and 2x. Now we are going to compose a new function, h of x, which is f of g. That is the lingo I'm going to use, f of g, that you see fog. You would have used a different lingo in your school, but sorry, this is how my teacher taught me. So f of g is going to be f of g of x. We substitute g of x in place of f. So 2x of f, 2x + 1 is the outcome. Now, we are going to compose g of f with the same functions, f and x. Now we get the result as 2x + 2. And clearly, f of g is not equal to g of f. This is a powerful functional composition theorem, or like the concept. If you interchange the types, your programs won't compile, which we'll be seeing in the later stage. So it allows us to write the composition correctly. So your music is going to be the same music. You cannot change the note. If you change the note, it collapses like blockchain. So this is a pictographic representations for the same mathematical composition that we did, for those who did not like that f of g. So you have one set, you calculate g of x, then with that result, you apply to f. This is f of g. The inverse would happen for g of f. Both will have different results, like f of g is not equal to g of f. Now, enough of mathematics, let's go to code this time. Now we have two simple functions, same, x + 1 and 2x. In Kotlin, we are calling it as f and g because the name that we give to the function doesn't matter for the function because it's an expression. It can do anything with respect to computation. The name is just for ours to understand, process what this does. And it's also the method reference. That's what's called function reference. So that's why I'm naming it as f and g, intentional. Now, we are calling f of g of 2. If you think this is how the function is composed, no, that's a big disappointment. This is not how we write function composition. What we did right now, previously, was the application. We just call the function one after the other. But compose, once again, it's a binary operation that you perform on functions. Let's see how this is done. So we write a function which computes these two functions into f of g of x, which is a function that takes in f and g. Both takes in integer as a parameter, returns integer. And finally, it has to give out a function which takes in integer, returns an integer. Now we have that x, which computes f of g of x. Now, how do we use it? By writing this composition, we do f of g by passing in f and g. Now, if you want to compute g of f, we create g of f and compose by passing in g and f, like invertically. So that's how we print f of g, you get 2. So now you might be thinking, okay, for function composition, I have to write more lines of code. Hold that thought, we'll come to the later. Now, we have a function problem in that previous composition that we wrote. It always takes in an integer, returns an integer. Like what about other types? So that's when polymorphic higher order function solves for us. Purely mathematical term, but that's how they adopted it in the functional programming thing. So it does look fancy, but you would know. So it's about using generics, for example. So now we have two different functions. Very simple one. It takes in a Boolean, gives an integer, and converts that integer back to Boolean. Let's try to generalize this with types. Now, this is a tricky one, what you're seeing here. So this composition, we are doing f of g. So how do you write this composition? I'm just going to explain. So first, we are doing f of g of x. So g of x is computed first. So if you look at g, you take in the first type, t, and it sends u, right? And the result of u has to be the input of f, and then the remaining type is v, it gets v. Now, if you look at this composition, the input has to be the input parameter of g, and the return value has to be the f. So that's why you have t to v, sorry. So I'm going to repeat that again. So f of g of x. G of x is computed first, so we write g first, which takes in the first two things, t and u. And this result will be passed on to f, which gives the remaining generic type v. And finally, when you're passing the parameter, you have to pass it to g. So it becomes t, and you pass it to v. Now, if you interchange any of these things, it wouldn't work, because it'd give you a totally different answer. But to validate that, this is how we write the compositions. Now then, you can pass on the types, compose of integer, Boolean, and integer, and pass on the references R1, R2. Method references. But if you try to interchange any of these things, it's not going to work. And this is how the composition is done for generic types. Now, we have another problem in this. Like, all the functions takes in only one argument, right? It always takes in either integer, Boolean, or any other types. But what about functions with multiple arguments? Sorry to disappoint you, in functional programming, we don't have a concept of multiple arguments, meaning you cannot imagine function having, because it's a list, it's a domain. You have 2, 3, 4. There cannot be 2 domain values that coming in, shooting in at the same time, right? But you can solve this using a concept called mathematical currying, or currying purely in Kotlin. Now, functional composition is one foundational concept. This currying is the next one. Let's take a look at this function. F of x comma y, mathematically first, equals 2x plus y. Now, we have 2 variables here, like 2 entries, x and y. How do we do this mathematically? You substitute the values like we do in the mathematics class, you get the result. But underlying, if we break this down, this is how we are substituting. We split that f of x comma y into f of x comma y. Then we make an assumption, always assumption in mathematics, right? So f of x is g. When you do that, the x goes off, like x becomes a constant. So all you have is g of y, and only the y gets changed. The x is computed, like it becomes a constant, it becomes irrelevant. So this is the underlying concept of currying. Now we do now the 66, what you see, it has become a constant. Then on it's just y. And this is the currying. So if you have like 3 f of x, y, comma, z, you'd keep doing that. It's just like a chain reaction where you pass on the arguments, make others irrelevant, till you exhaust your incoming arguments, basically. Let's take a look at it. The definition. We apply x for the function y, we get the resulting function g, and then we apply y. Then y becomes h, we apply z, it becomes something else. So this chaining of this process is mathematical currying. And currying in programming is basically you take in an argument, you substitute, you create a function where it takes in the second argument, get a function output, put in the third one, and then, so it's like nesting functions, and it returns a new function that is expected for every argument. Finally, when the argument is like exhausting, that's your effect or result from the currying, basically. Let's take a look at it in action quickly. Now, x and y, 2 variables, right? So it takes in an integer and returns a function which takes in an integer and returns an integer. I know it's a lot of integer, but this is the simplest type that we can work with. Now, with this, let's compute the 2x plus y. So the resulting function is this, where we first take x and try to compute a function. This is a resulting function which takes in y, and you have the 2x plus y. Then you call currying of 33, 48. You get the result as 114. You also have processed how you handle the generic types of currying. You can chain a lot of things, but that is not covered here because I'm covering a little bit of pure effects, so I have to skip to that. Now, you can relax for a moment. This is a very fun topic, how we can leverage the power of Kotlin APIs to creatively compose and make it nice and pretty for a different change. Now, you would have seen the composition where you pass on the types and create. So this is a nice API. Like you have to perform square of and triple. Like you've taken an argument and you perform square of triple. Square is a separate function, triple is a separate function. But then you use and then triple, and then square again if you want, and then you do some quadratic equations by passing on the single value. So you keep square and triple separate, easily testable. You need not test this computation because it's going to work. That's the power of functional programming. Now, any idea how I done this is extension functions. The same compositions that this is the first composition that we wrote, and this is the extension function that I create. So basically take G and add dot then and add on F. So then on you can chain the functions that you want to create. This is how you build the Lego, like, or the music that I was talking about. This is super nice, powerful, and you can also do something like this. Like, any idea how this can happen? One keyword, infix operator. So when you add infix operator to, oh, sorry, did I skip that? So this is nothing but adding an infix operator in front of that extension so that you can use dot and instead of and then you use then. This is how we use it for the hash map. You drop in a hash map in Kotlin. All right, now another one, creative composition using operator overloading. I wouldn't advise this, but it's just fun to do it. Just want to show you. You can use plus for actually computing those functions. I wouldn't advise this because plus makes a lot of, it has a different meaning in different context. And this will kind of mess up your APIs. How do we do this? It's operator keyword and same extension function. Instead of and then, you use plus, and we get that result. Cool. Now, a small summary before we jump into the next FX. If you want to write, if you want to go functional, like if you're writing Kotlin backend, you would have a lot of computations to do. Or if you're creating an Android POS, you have computations there. So writing computations in a functional way, it's much safer, much nice. You have the power of composition and scale it. And this is what it explains. So if you are using computations, use pure functions. And all the effects or the results that you get out of the pure functions or partial functions, you handle it using the pure effects. And sometimes you cannot handle pure effects, but you can. You try as much as possible using the functional paradigm. Now, let's talk about pure effects. As I mentioned, pure effects is like outcome of a function. And this is the simplest definition. Like referential transparency is a technique where you predict the outcome. And this is basically you don't break. So get the effect, get the result of the program without breaking the referential transparency. It's a diplomatic definition. Now, I'm not going to dive super deep into handling the effects, but here is one example. Like usually we have a lot of null. And some of you throw exceptions, some of you catch it, put it in a sealed class, or Kotlin gives us a way to propagate the null and how you want to handle. There are a lot of ways, but let's imagine I had a different use case where I had to chain multiple workers. Like I work for a file transferring companies where transferring a file from one place to another, it is a lot of steps, hashing, breaking down things into a lot of stuff. And each step, you maintain a data class which is nullable. So in each step, you need to check for nullable and handle a lot of stuff. That was a pain. But there is a type called option, which is part of the functional programming paradigm. So let's see how, we're not going to see code now, it's just flowcharts. Now I have the list of files. I take the first. I have a chance that it can be null. Then I use that file to break into multiple bits of chunks, like 5 MB chunks. And when I'm breaking in that process, reading the file and doing some things, it can go wrong. The file is corrupt, maybe. And then I have the list of files. I calculate the series of hash to store it to the server. It can go wrong if the bytes are not proper. Then finally, I get the list of hash strings. Probably we have multiple layers in the apps, right? So you have networking, repository, use case, even domain, a lot of things. And you could be throwing null at every stage, and sometimes you fail or you won't see it. We are humans, we make mistakes. And with option, it can make it simple. Like it'll allow you to propagate to the last step, and you can actually decide how you want to handle that null. Do you want to handle it in the UI, or do you want to handle it in the respective layers? So option will give you either a value or nothing, none, as a type that you can handle. It's a simple sealed class. If you want to imagine how that option would look, option, sealed class, you have a value, then you have none as an object. That's the underlying implementation of it. Now, I hope, yeah, we're almost time. So, how many of you have tried Arrow? Oh, that's a decent number. Now, with these concepts, now you know why Arrow exists, right? So we were composing ourselves using additional lines of code, because you imagine, we have to write a lot to compose. You write a composition, then you have to invoke them, and that's how it is. Arrow it takes away that pain for you, and it gives these compositions, right, in a nice API. So we have throws some stuff, a function, throw other things, more throwing. Now you have that and then, what we created using composition and extension. It just comes out of the box for you, so you can use. For this to use better, you should be understanding what is happening, what is pure functions, why you're doing this, right? Now it makes much more powerful. I had that eureka moment right here, like poof. And for handling fx, arrow also, this is just one example, either I'm taking. You also have option in arrow where you deal with nulls for that. Either is basically, you use it. I've used either, I liked either, I used it pretty much everywhere, but it's not the case. If you look at the verbally, either can be two results. It's basically a function which emits two fx, and two fx are success, right? And if one is error, you would use option, or you would use result of Kotlin, or you have a result type, another result type in arrow, I don't remember. So you treat that as error. But here in either, you treat that as a result as well out of that particular function. Now, let's revisit this definition. Now I hope you get the full picture. It's about writing pure functions for computations and handling pure effects, like what we saw. And it avoids the state of shared, because whatever is fed into the input, you have a definitive mirror, like in the domain and codomain relationship. That's what you need to remember. And finally, it is an expression and declaration, the function as a mathematical function. When you try to imagine a function, just imagine it as a mathematical function. It makes the learning curve of the functional programming much easier. My final thoughts, this is just going to be like 2 minutes max. So can you go full functional? I've had a lot of questions. Can you make an Android app completely functional, 100%? That is way too difficult, in my opinion. And for backend, yes, you can make a lot of pure functions and pure computations. You can. And what we take home is basically, if you want to use arrow, you can, but be cautious. Like, all your layers would depend on a type. And once you step in, like, taking it out is going to be very difficult for sure. And your teammates have to be comfortable. Like, they will be comfortable picking up a new library, but are they comfortable, or do they have enough sufficient knowledge for using functional programming in the right way? If not, you can make mistakes. You can misuse arrow APIs, use different types at different context. So you need to think about that. And if your teams are very comfortable, then you can sell it to the management to pick up arrow. If not, like, you have a specific problem, like I'm getting a lot of, I couldn't manage my null things, or I couldn't propagate my result properly from bottom layer to the top layer. Extract specific types from the arrow. It's very simple, it's relatively just pure Kotlin. You can just have it in your code base. Just start using that, get comfortable. And if you really want to pick up the whole bunch of other types that arrow offers, you can. But start less with some tackling right problems. So that's why I wanted to help put this talk together to understand what functional programming solves. Based on that, you can pick up the right solution that functional programming offers for your projects. That is my final thought, in my opinion. And I would recommend these two books. They're amazing. The Joy of Kotlin is super nice because it's an ocean of functional programming, raw concepts written completely in Kotlin examples for you to better understand. And that one, Functional Kotlin, would talk a lot about arrow and its types. I'll take a moment to take the pictures. Yeah, cool. And finally, the slides, what you've been seeing, will be in this QR code. You can download it. Yeah, sweet. And a moment. Cool. Thank you.